Every year, billions of bullets are manufactured around the world. Despite their small size, each one is produced with a level of precision usually reserved for advanced engineering systems. Long before a bullet ever reaches a box or a shelf, it begins its journey inside highly controlled industrial environments designed for consistency, accuracy, and scale. Unlike many everyday products, ammunition manufacturing allows almost no margin for variation. Even microscopic differences in shape, weight, or alignment can affect performance. That is why modern ammunition factories operate more like laboratories than traditional production plants. The process begins with raw materials. Most bullets are built from a combination of brass, copper, lead, and sometimes steel. These materials arrive at factories in massive quantities, delivered as coils, sheets, or ingots. Before production starts, each batch is inspected to ensure purity, uniform thickness, and structural integrity. One of the first major components produced is the cartridge case. In many types of ammunition, the case is made from brass, chosen for its strength, flexibility, and resistance to corrosion. Brass also expands and contracts in predictable ways, which is critical during firing. The case starts as a flat brass disc. Through a process known as deep drawing, the disc is gradually shaped into a hollow cylinder. This does not happen in a single step. Instead, the brass passes through a series of forming stages, each one slightly stretching and reshaping the material. At every stage, machines carefully control wall thickness. Too thin, and the case could fail under pressure. Too thick, and it may not function correctly. Sensors continuously measure these dimensions, ensuring each case remains within extremely tight tolerances. Once the basic shape is formed, the cases are cleaned to remove oils, residues, and metal particles left behind during forming. They are then heat-treated. This process alters the metal's internal structure, improving durability and preventing cracks when the cartridge is later used. After heat treatment, the cases are cooled and stabilized before moving on. By this point, thousands of nearly identical cases are flowing through the factory every minute, each one following the same precisely controlled path. While the cartridge cases are being prepared, a separate production line focuses on the projectile itself. The projectile is the part commonly referred to as the bullet. In many designs, it begins as a lead core, selected for its density and consistency. These lead cores are formed into exact shapes and weights using high-speed presses. Some projectiles are then jacketed with copper. The jacket improves strength, reduces friction, and helps maintain shape during travel. Forming the projectile requires extreme accuracy. Weight differences as small as a fraction of a gram can cause rejection. Automated inspection systems scan each projectile, checking dimensions and surface quality. Any component that fails inspection is immediately removed from the line. Once both the cartridge case and the projectile have passed quality control, they move toward final assembly. This stage brings together multiple components that have been produced independently but must now function as a single unit. The projectile is seated into the cartridge case using carefully controlled force. Too much pressure could deform the case. Too little could affect alignment. Machines perform this step repeatedly, adjusting in real time based on sensor feedback. Next comes the primer. The primer is a small but critical component installed into the base of the cartridge. It is designed to ignite the propellant when struck, initiating the firing sequence. In the factory, primer installation is handled with extreme care and automation. With all major components assembled, each finished cartridge undergoes another series of inspections. Machines measure overall length, weight, and alignment. Rollers test straightness. Optical systems scan for surface imperfections. Despite advanced automation, human oversight remains important. Technicians monitor production lines, review system data, and intervene if patterns suggest potential issues. Their role is not to assemble individual rounds, but to ensure the systems themselves are operating correctly. Only cartridges that pass every inspection step are approved to continue. These approved rounds move into the packaging phase. Here, automation once again dominates. Cartridges are placed into trays, sealed, and prepared for storage or shipment. Storage conditions are tightly controlled. Temperature and humidity are monitored to prevent material degradation over time. Ammunition may remain in storage for extended periods, so environmental stability is essential. Before shipment, factories often conduct secondary verification checks. Random samples are selected and examined to confirm consistency across entire batches. This extra layer of verification helps reduce risk throughout distribution networks. Once cleared, packaged ammunition is organized into pallets and prepared for transport. Logistics systems coordinate movement by truck, rail, or ship, depending on destination. Every shipment follows regulatory guidelines that vary by region and purpose. Modern ammunition factories are designed to operate continuously. Automation allows production to scale without sacrificing consistency. Software systems constantly adjust machine settings, compensating for wear, temperature changes, and material variation. This balance of hardware, software, and human oversight defines modern ammunition manufacturing. The goal is not speed alone, but reliability repeated millions of times. What appears to be a simple object is actually the result of dozens of tightly controlled steps. Each step builds upon the previous one, leaving little room for deviation. Small errors, when multiplied at scale, can become serious problems. That is why these factories prioritize precision above all else. Every variable is measured, monitored, and refined. Repetition is not a weakness here. It is the foundation of quality. By the time a single cartridge leaves the factory, it has passed through multiple systems designed to ensure uniformity. Multiply that process by billions, and the scale of modern ammunition manufacturing becomes clear. Factories like these operate largely out of public view, yet they form a critical part of modern industrial infrastructure. Their processes reflect the broader principles of mass production: control, consistency, and efficiency. Understanding how bullets are made reveals more than just a manufacturing process. It offers a glimpse into how precision engineering operates at extreme scale, where even the smallest components demand exacting standards. From raw metal to finished cartridge, every step is engineered, monitored, and refined. This is not just manufacturing, it is systems engineering in motion. This is how bullets are made inside modern ammunition factories.